Hi dear students, Santosh here. Today I am going to deliver my lecture number 4 on highway engineering or road engineering, and which deals with the elements of the highway, gradient and side distance, which are the geometric design part of the highway. This lecture is very important as far as MPSC mains is concerned, and also very useful for the degree as well as diploma level students, and also useful for the various professional exams, competitive exams, GATE and IES, etc. So please be subscribe my channel to get more and more things regarding various subjects of civil engineering. So let's start with the elements of the highway. What are the different elements of the highway? That is the crucial part of any highway engineering or highway design. You must know the separator, you must know the curves, you must know the road margins, you must know the formation width or road formations, and you may aware with the right of way, which is very important term in development of the national highways as well as state highways. First of all, we discuss the separator. The main object of this separator is to prevent the head-on collision between the two vehicles moving in opposite direction in the adjacent lanes. These separators may be in the form of pavement marking, or these separators may be in the form of mechanical separator. The pavement markings are very simple and cheap, but the mechanical separators should be designed in such a fashion that if the wheel of the vehicle encroach on the mechanical separator, but no damage should be done to the vehicle. That is very important in case of mechanical separators. Then we will discuss about the curb. What is the curb? Curb indicate the boundary between the pavement and shoulder. The curb may be divided into the three groups: low curb or class 1 curb. The height is less, so it is termed as a low curb. The height of this class of curve is 7 to 8 centimeter. The vehicle can climb easily on this curve. These are useful for the longitudinal drains. So low curves are used near the longitudinal drains. Then second type is urban parking curves or class 2 curves. These curves are 15 to 20 centimeter in height with 1:1 batter to prevent the scrapping of tire, and this type of curves prevent the encroachment on the footpath or parking space by slow moving vehicle. So please look at this figure. This curve is the class 2 type of curve. These two curves are near median. If longitudinal drain is located here, this curve may be designed as a low curves, and this curve near footpath may be designed as a urban parking curve. And third type of curve is high speed barrier or class 3 curves. This class of curve is used in hilly roads or on the bridges, and they are 25 to 45 centimeter in the height and do not allow the vehicle to leave the pavement. They have steep batter. That is very important. So please look at this figure. This is the 3-lane pavement, and another 3-lane pavement is here, and this is the median. If longitudinal drone is placed here the curves are placed on the both sides, and here is also curve placed between the footpath and the pavement. So this figure is self-explanatory in terms of curves. Then road margins. Various elements included in the road margins are the shoulders, parking lanes, driveway, frontage road, cycle track, footpath, guardrail and embankment slope. So road margin is very important. Each people in the highway engineering must know what are the different types of road margins. So first of all, we discuss the shoulder. Shoulder, you know that shoulder is provided near the pavement and edge of the pavement and on both sides to give the lateral support to the pavement. Shoulder also serve as an emergency lane for the damaged vehicles. The minimum width of the shoulder should not be less than 4.6 meter, so that even parking of the widest truck of width 2.75 meter can be done. But due to land restrictions and difficulty in getting the land, the shoulder, as per IRC specification, the minimum width of that shoulder shall not be less than 2.5 meter, and the shoulder would have a clearance of 1.85 meter from the edge of pavement. So it should be at least 1.85, but as per IRC it is 2.5 meter. Parking lane. In the urban areas, the parking lanes are also provided. The parking lane should have sufficient width of 3 meter. you must know that the parking lane must have width of 3 meter, and generally partial parking should be allowed as it is safer to drive. Then driveways are nothing but the like slip roads or service roads, and these connect the main highway with the service or fuel stations. You must know, or you must visited the Mumbai Pune expressway. Near Sasgaon or Khopoli, there are two food malls on the both sides, and these food malls are connected with the roads. Such a roads we may term it as a driveways, and driveways are very important, and the width of the driveway is kept minimum, but the radius of the curve should be kept as a maximum. Then we will discuss about the frontage road. Frontage road is nothing but the service road or a slip road. These roads are provided to give access to the properties along the important highways. These roads may run parallel to the main road or a main highway and isolated by a separator with approaches at the selected point. So this service road must have approaches at the selected point to enter into that service road to access the properties adjacent to that highway. Then cycle tracks. In the urban areas, the cycle tracks are provided. If cycle traffic is very high on the road, the minimum width of the cycle track should not be less than 2 meter. So at least 2 meter width cycle track should be provided. And in case of double lane, width of the cycle track may be kept as a 3 meter. In case of double lane cycle track, the width is kept as a 3 meter. Okay, then we will discuss about the footpath. In urban areas where vehicular traffic as well as pedestrian traffic is also very high, footpaths are provided. Footpaths are very important, but nowadays it is used by hawkers or there are encroachment. Such an encroachment must be removed by the local authority to keep that footpath open for the pedestrians. They are generally provided on the both sides of pavement. The width of the pavement or that width of the pavement of that footpath should not be less than 1.5 meter. Then guardrails. Guardrails are provided at, they may be termed as a crash barriers, and they are provided where embankment height is more than 3 meter. In such a case, to avoid the vehicles from running off the pavement, these guardrails are provided. Sometimes they may be called as a crash barriers, and there is another technology that is anti-crash barriers, but the crash barrier technology is nowadays used while crashing of vehicle, that guardrails are crashed. Okay, then embankment slope. The embankment slope is near the shoulder. The purpose of providing embankment slope is the safe movement of traffic and also for aesthetic reason, and it is also for the drainage reason also, because if we kept the road at certain height, the rainwater does not enter into the highway, and which leads to the safer highway and the highway which is watertight. Then we will discuss about the road formation or a formation width. The road formation or a width the width formation includes the width of pavement, shoulders and separators if any. In case of embankment, the formation width is equal to the top width of embankment, and in a case of cutting, it is bottom width of cutting but minus the side drains. By looking these figures, you will get all the terminology. But you must remember two terminologies if you want to design the highway or you want to study the highway. First of all, what is the roadway and what is the road line width or right of way. Road line width and right of way are both are the similar terms, and roadway is nothing but the carriageway plus the side shoulders. So roadway is carriageway, means bituminous or concrete surface plus side shoulders. And what is the road line width? Road line width is the roadway plus the road margin on the both sides. So what is actual width of road? That is the right of way. And what is the roadway width? Roadway width is consisting of the carriageway plus shoulders. You must remember these two terms because there are several court cases regarding the acquisition of the highways, and general people only know that the width of the highway is only the carriageway width, but it is not a case. The width of the highway means width of the carriageway plus width of the shoulders and plus width of the road margins. That road margin may include the side drains, side gutters and tree plantation also. And there is another terminology that the width between the building lines is overall width between the building line is also there, and overall width between the control line is also there. Okay, so for our convenience, you must know what is the roadway width and what is the roadland width or what is the right of way. And roadway is nothing but the formation. Then we will discuss the right of way, which is already discussed. What is the right of way? Right of way is the roadway width plus road margin. That is the right of way. The factor on which the lane width depend upon the cost of lane, width of formation, height of embankment of depth and depth of cutting, topography of the area, drainage system, reserve land for the further development. So the right of way is decided considering the future growth also. That is very important because in future the cost of land acquisition going to be very high. Then we will discuss about the gradient. What is the gradient? Gradient is the slope given to the road in the longitudinal direction, or it is the ratio of rise and fall along the length of road. And the rising gradient is known as a positive gradient and falling gradient is known as a negative gradient. It is so simple. Okay. Gradient, what is gradient? We derive analytically or mathematically. Gradient is vertical distance divided by horizontal distance multiplied by 100%, or it is the rise of road or fall of road divided by length multiplied by 100. The gradient is expressed as a ratio of length in which elevation of the center line of road rises or falls by 1 unit. For example, 1 in 100. It is expressed as a percentage. Thus, 1 in 100 gradient are expressed as a 1% gradient. It is very important. 1 in 100 gradient is the 1% gradient. Gradient on the road are necessary due to nature of terrain through which the road passes. While traveling along a rising gradient, extra effort or extra fuel consumption is required. It is very common. Steep gradient should be therefore avoided. Steep gradient should not be there. The gradient to a road is necessary to drain off the rainwater easily through the side drains. Even in plain areas, the flat gradient of 1 in 250 or 1 in 500 means 2.5% to 5% are provided for satisfactory drainage and to keep the road in good condition with less maintenance cost. So gradient has a prime importance. Please look at this figure. If this is the ground like such a in such a fashion, okay, so we have to provide the road in such a fashion that this is the rising gradient and this is the falling gradient. Okay, so if for rising gradient the length is this one and the rise is this one, so rise divided by length multiplied by 100 you get the gradient. It is so simple. For cutting, such a formula should be applied. Purpose of providing gradient, as we discussed earlier, to connect the two roads which are at different levels. That is the gradient. To provide the effective drainage of rainwater falling over the road surface. So drainage, connectivity. Third is to make the earthwork of the road project economical. So quantity of cutting is equal to quantity of filling. We studied in the diploma and degree also. To reduce the maintenance cost of the road surface and to construct the side drains economically with convenient depth below the ground level. We can use the gradient in such a fashion, or the gradient is useful in above ways. The factors affecting the gradient. Following are the various factors that affects the selection of gradient in the alignment of the road. The nature of traffic, that is very important. The nature of ground, that is also important. The road railway connection and bridge approaches, that is also important. The type of road surface, whether it is concrete or bituminous, that is also important. The drainage required, that is important. The total height is to be covered, that factor is affecting the gradient, and the safety required. First of all, here I am not included that in my PowerPoint presentation, but it is very important to know you the various types of gradient. First type is ruling gradient, second is the limiting gradient, third is the exceptional gradient. What is the difference between the ruling gradient, limiting gradient and exceptional gradient? Ruling gradient is the gradient which is generally provided for the road, or it is maximum. That ruling gradient is the maximum gradient generally provided to the road terrain, that is ruling gradient. What is the limiting gradient? Limiting gradient is greater than ruling gradient, and which is applicable in limiting cases. That is the limiting gradient. So limiting gradient is always greater than ruling gradient. And what is the exceptional gradient? The name itself indicates it is used in exceptional circumstances. What are the exceptional circumstances? That is, we have to provide the gradient lower than the lowest, or you have to provide the gradient steeper than the steepest. In such a case, we can provide the exceptional gradient. Okay. Then IRC specification for these different types of gradient is nature. It depends upon the nature of terrain. For plain terrain, the ruling gradient is 1 in 30, limiting gradient is 1 in 20, and exceptional gradient is 1 in 15. And for rolling terrain, it is 1 in 30, 1 in 20, and 1 in 15, same as that of plain. But for mountainous region, it is 1 in 20, and limiting is 1 in 67, and exceptional gradient is 1 in 14.3. And for steep gradient, it varies from 1 in 20 to 1 in 16.7. Limiting gradient varies from 1 in 16.7 to 1 in 14.3, and exceptional gradient varies from 1 in 14.3 to 1 in 12.5. So you must remember the IRC specification for these three types of gradient. Other than these three types of gradient, there are another gradients are also there. That is, one is the maximum gradient and another is the floating gradient. So you please study that terms also. What are the floating gradient and what is the maximum gradient? But the maximum gradient is the name given to the limiting gradient, and floating gradient is the gradient on which vehicle moves without application of the brakes. So you can study from the books also. Okay. Then we will discuss the second geometrical design important term, that is the sight distance. What is the sight distance? Sight distance is a clear distance ahead of the driver of a vehicle over which he has a clear and unobstructed view. So it is distance ahead visible to the driver to drive his vehicle very safely and unobstructed. Okay, the sight distance assumes considerable importance in the design of the vertical curves. It is important. Sight distance is important in design of vertical curves. It also governs the setback of the obstructions like a building line, control line, and fences, etc. adjacent to the carriageway at the junctions and horizontal curves of the road. What are the factors affecting the sight distance? Sight distance ला कुठले कुठले फॅक्टर अफेक्ट करतात? तर हॉरिझॉन्टल अलाइनमेंट ऑफ रोड, this alignment, horizontal alignment of road is very important. Then vertical profile of road is also important for sight distance. Then traffic conditions are also affects the sight distance, and the position of obstruction is also important for the sight distance. What are the type of sight distances? Two types of sight distances are very important. First is the stopping sight distance and second is the overtaking sight distance. First of all, we look at these figures. First figure, please look at this first figure. This is the horizontal curve, and what is the sight distance? This is the vehicle. Okay, and this is the another vehicle. Okay, so this is the sight line of two drivers. Okay, and the distance between these two vehicles is termed as sight distance. Why? Because here is the obstruction to the vehicle. If this obstruction is here, then this sight distance might increases. Okay, so sight distance at the horizontal curve with obstruction, you must know what is the sight distance and what is the purpose of that obstruction. Then second is the sight distance at vertical summit curve. Look at this figure. This is the vehicle and this is the object having 0.1 meter height or 10 centimeter height, and this distance is called as a stopping sight distance, and this curve is the vertical curve or vertical summit curve. The height of the eyesight of a driver is taken as 1.22 meter in case of sight distance at vertical summit curve. So you must know this 1.22 or height of object is 10 centimeter. You must know these figures for MCQs. Then we will discuss about the stopping sight distance. This is also known as a non-passing sight distance, and first is called as a passing sight distance. Overtaking is the passing and stopping sight distance is the non-passing sight distance. This is the minimum distance which the driver of a vehicle requires to bring his vehicle to stop when he sees the object in front of him. Accident on a road takes place because of his inability to stop his vehicle when he sees the object before colliding against it. This may happen due to following reasons: failure of the vehicle. This may occur due to mechanical failure of a vehicle, such as a failure of brakes or any other system. Problems with the driver, that is defective eyesight of a driver, or fatigue or similar factors, or driver may be in a drunken state. Inadequate sight distance. If the distance available for stopping the vehicle inadequate, vehicle will collide with the object before it comes to stop. These are the reasons. Please look at this figure. This is the vehicle. And this is the vehicle, and the height of eyesight of a driver here is shown as 1.22. Here is a vertical summit core, and this is the 10 centimeter object which is not seen to that driver, and this distance may be termed as a non-passing sight distance. And what is the height of obstacle? That is 10 centimeter or 0.1 meter. Then we will discuss about factor affecting the sight distance. Depends upon the height of eye level of a driver. This is taken as 1.22 or 1.2 meter. The height of object, which may be taken as 10 centimeter or 0.1 meter. Factors like condition of road and speed of the vehicle, etc., that are also important for sight distance. The stopping sight distance is made up of two components: distance traveled during the perception time and the brake reaction time of driver, during which vehicle travel with full speed. Means perception of the vehicle is done by the driver, and after perception he may apply the brake, and such a distance traveled by vehicle with a full speed is the first distance, and second is the after application of brake, that is braking distance. The distance traveled during the time between the application of brake and stopping the vehicle, that is the braking distance, and the vehicle traveled during this time with diminishing speed, that is smaller speed or zero speed or dead speed. Stopping sight distance, mathematically expressed as 0.278 Vt plus into second bracket 0.278 V square bracket complete divided by 2gn, and IRC recommendation for stopping sight distance is for design speed of 20, the stopping distance is 20, 25 it is 25, 30 kmph, the distance is 30 meter. For 40 it is increased by 5, for 40 it is 45 meter, for 50 it is increased by 10, that is 60, for 60 it is increased by 20, that is 80, for 65 it is again increased by 30. So you must remember all these figures for MCQs. What is the design speed and what is the safe stopping distance in meter? That are the IRC recommendations for stopping sight distance. And second, as we discussed earlier, overtaking sight distance. Overtaking sight distance is also known as a passing sight distance. On a road more than one traffic lane, it is desirable to provide the facilities for the driver of fast moving vehicle to overtake a vehicle ahead of him moving with a slower speed. You must remember the Mumbai-Pune expressway. There are 3 lanes on each side, and one lane is used for slow moving vehicle, middle lane is used for average speed of vehicles, and third lane, which is close to the median, is used for the fast moving vehicles or for overtaking. That third lane is dedicated to overtaking vehicles. Passing sight distance can therefore be defined as the minimum distance speed open to view ahead of the driver of a vehicle that enable him to overtake a slower vehicle ahead of him safely against the traffic approaching him in an opposite direction with full design speed. But in case of Mumbai-Pune expressway, we can overtake the vehicle in one direction only. Here it is described as a vehicle, two vehicles moving in the opposite directions also considered. But if two vehicles are moving in the same direction, then the first lane is used for slow vehicle, second lane is used by overtaking vehicle to overtake the vehicle in the second lane, and by overtaking it by the third lane, it again resumes the position into the second lane or middle lane. So overtaking distance comprises the following 3 components, that is D1, D2 and D3. These 3 distances, D1 is the distance covered during the perception and reaction time, that is the D1. D2 is the overtaking distance during which driver moves in the adjoining lane and overtake the slower vehicle and join back his own lane of the traffic, that is D2 as discussed earlier. And D3 is the distance traveled by the vehicle approaching him in the adjoining lane from opposite direction. These are the three distances, and the combination of D1 plus D2 plus D3 gives us the overtaking side distance. So the overtaking side distance is the D1 plus D2 plus D3, or it is VB small t plus VB capital T plus 2S plus VT. You may please refer any book for these derivations, or in kilometer per hour, overtaking side distance is 0.28 VB small t plus 0.28 VB capital T plus 2S plus 0.28 capital VT. So what are the IRC recommendation for overtaking side distance? For design speed of 40, it is 165 meter is the safe overtaking side distance. For 50 speed, it is 235. For 60 speed, 60 kmph speed, it is 300. For 65 speed, it is 340. For 80 speed, it is 470. And for 100 kilometer per hour speed, the safe overtaking side distance in meter is 640. So please remember these values for your competitive type of examinations or diploma degree examinations, as well as for MPSC mains examinations. And for more details and notes, you may please contact my administrator. You can email me for any further guidance, or you want any other details. And again, I am requesting you to please subscribe my channel for further lectures of highway engineering and other subjects. And also, it is very useful to you for MPSC mains and other type of competitive examinations. So don't miss my lectures, please. Don't miss, and please subscribe again. Okay, bye. Bye bye.